Suppose we're designing a water fountain and we know that we're going to be launching our water at 30 degrees close to the ground, and we want it to land 7.8 meters away. So it's kind of like this big arc of the water. I want to know how fast must my water be moving when it leaves the little launcher area. So I'm looking for V naught. Now, this might seem like a hopeless problem because we're just not given a lot. But let's break it down into what we know in the x direction and in the y direction and see if we can maybe solve this problem. So the first thing I do is I create a table. I always know the first column, or I'm sorry, the first row in my table is the acceleration. In the x direction, it's always going to be 0 meters per second squared, and in the y direction, it's always going to be negative 9.81 meters per second squared. This is because there's nothing affecting the ball in the horizontal direction. It's just kind of moving on its own, and we have gravity acting on us in the y direction. Okay. To find my initial velocity, normally I would just put a question mark because I don't know it for sure. But what I want to do is I want to figure out this overall initial speed. So these spaces are for the components of that initial speed. So if I have an initial speed of v naught, I can actually express the components in terms of v naught. So this is the x component, this would be the y component. The angle is 30 degrees. So to find the x component, that's my adjacent side, and we have the opposite side. So I'm sorry, we have the adjacent and we have the hypotenuse. So that would lead me to use cosine. So I go cosine 30 equals VOX over V naught. So that means my x component can be expressed as V naught cosine 30. Now I can evaluate the cosine 30 part in my calculator, and we'll do that later. Let's do the same thing for Vy. Vy is the opposite, and I have the hypotenuse, so that's going to lead to the sine of 30 equals V naught y over V naught. Solving this for V naught y, that leaves me with a y component of V naught sine 30. Okay. So now with my table, I come to the displacement column. So my displacement in the x is going to be 7.8 meters. And in the y, it's going to be 0 meters because the water is returning to the same height from which it was launched. Then, I don't know the time it's in the air, but I can use that to actually link the two equations. And so I can find, if I can find Tx, and if I can find Ty, I can set them equal to each other and then solve that equation for V naught. So step 1 here is going to be to find Tx and Ty. So for Tx, let's see, I have acceleration, initial velocity, displacement, and time. So that's going to lead me to the second equation. We'll leave those off. Now I can simplify this because my acceleration is 0, so that just goes away. So what I get is I get 7.8 equals V naught cosine 30 times t. Let's solve this for t. So t equals 7.8 V naught cos 30. All right, so that's going to be Tx. Now what I want to do is I want to find Ty. So for Ty, I use the same equation, except now I'm going to use the y information over here. So that's going to be V naught sine 30, and delta y is 0, times t plus 1/2 negative 9.81 t squared. This might seem a little impossible, but because we have the 0 over here, what I can do is I can move this whole term over to the other side. So I'm going to and it's negative over here, so when I move it over, it becomes positive. I go 4.905 t squared equals v naught sine 30t. That allows me to cancel out a t. Solving this for ty, I would get v naught sine 30 over 4.905. So now that I have my two expressions for t, tx, and ty, I know that they are equal because the time to go up and down is the same as the time to go horizontally. So I can set them equal and then solve for v naught. So what I have is I have tx equals ty. So that's 7.8 over v naught cosine 30 equals v naught sine 30 over 4.905. Let's go ahead and solve this for v naught. So I cross multiply. I get 38 equals v naught squared sine 30 cosine 30. I can plug this into my calculator. So we have v naught squared is 0.430 equals 38. Divide both sides by 0.4330. So v naught squared would equal 88.3553. Take the square root of both sides. V naught would be 9.40 meters per second. It's a little bit longer of a problem, but now you guys are equipped to solve any projectile motion problem.